Hi everyone, this is Emily. In this recording, I'm going to talk about how to do acidic hydrolysis for amides. And with this one, it's kind of a long process. It takes a long time to explain and to work out. But if you practice it, I think it should be fine. You just got to keep practicing. That's the big thing with these. So these break down, whenever you're trying to solve them, they break down in two steps. So in kind of like two things you have to do. That's what I always tell people. So the first thing you want to do is you want to add water to this compound, and we'll do that in a minute. And then the second thing you want to do is add uric acid. So first thing we're going to do is we're going to add this H2O. So whenever you do this, you always have to break. I mean always. You always have to break between the carbonyl group and that nitrogen. That's always your breaking point. So when we do that, we're going to add water. And your OH part of water is always going to go towards the carbonyl group. Okay. And then your leftover hydrogen is always going to go to the nitrogen. Okay. And I did forget to draw this earlier, but because we know we have a power of 3 on this nitrogen, don't forget to put a hydrogen if necessary, if you need to put something somewhere, because remember we have to have 3 around it. So if you're only seeing 2 carbon groups, that means you have to add a hydrogen. Okay, so I'm going to put that right here. And then this hydrogen is the one we're adding for water. Okay, so just remember that. So now we have 2 pieces right now. So we have a carboxylic acid and we have an amine right here. Okay. So now we have to add this HCl, but the problem with this is we can only add this to one of these. So we can add it here, or we can add it here. So the one I'm going to want to add this to is because this is an acid. I want to add it to the one that's not an acid, because I can't put like 2 acids together or 2 bases together because they won't react. So it's always going to be with its opposite one. So this acid, the HCl, is going to want to go with the base. Okay, and the base is this amine right here. So because this one's an acid and it can't react with HCl, this carboxylic acid here, this is a final product. So we're just going to keep that for the end. But what we're going to do is we're going to add this HCl to this amine. And when we do that, we're kind of crumpling this HCl. We're putting it all on the nitrogen, essentially. So this nitrogen, so we have 2 hydrogens already, and we have an ethyl. So you see here that this nitrogen's full. It's already got its 3 around it. But what these can do is they can have another hydrogen on it, these nitrogens. But what's really important to know is if they take on a 4th thing, we have to make that nitrogen positive. And that means when we have that positive, that means we have an ammonium ion. Okay, so now we made this positive, but we took this H from that Cl. So what happens now is because that Cl lost that positive charge that was keeping it stable, now Cl is minus. Okay, so that Cl, because that's minus, and this nitrogen is positive now, these 2 can react. So that Cl is going to come out and just hang with nitrogen, and they're going to bond together. So what we have here, see we have that positive negative, and I told y'all that was a salt. So this is a salt, but since this is an amine and not like a carboxyl group that we have, like with the carboxylate salts I talked about, this is going to be an amine salt. Okay, so this right here, this is our second final product. Okay, so we got our first one up here, and then this will be our second down here. Okay, I hope that this was helpful, and there you go.